All right, we're going to be kind of breaking it down. Not really solving anything today, but we're going to be implementing, hopefully, something that'll help us solve things. So we're having problems with picking up stones and limiting how many stones we can drop and how many stones we can ultimately pick up. So we need to add something. Now, I'm going to check when we press down if we are, in fact, we are, actually, I want to see if our occupants are getting populated upon a picking up. So if we're in a move type move, if we click on it, do we get, yeah, we increment our occupants for the amount of occupants that are in our grid that we picked up from. So let me pick up I'm gonna say that we want to print bottomStone occupants. Okay, we concatenate that with a string of our bottomStones dot occupants, and I want to see if this is decrementing correctly upon dropping. What is it wanting? 58. 38. Oh. No? Oh, yeah, we don't want any of this. Still doesn't like that. Oh. Yeah, we don't want any of this either. There we go. Okay, so let's see if our bottomStone occupants is at least functioning right. It's 0 right now, should be 3 when we pick this up. It is. Now is it 2 when we drop? Yes, it is. It is 1, and it is 0. And it stops letting us drop stones if we're at 0, but we need to at least pick up stones. Okay, so the hard thing is we can only pick up the amount of stones that we had upon clicking a legal move and a move type move. So like once we pick up stones, however many stones we actually pick up, that number needs to be saved in a value somewhere, and we only pick up stones if our occupants is less than that number. We're decrementing our occupants fine. So we don't really need to do anything extra for that, but we do need to fix it for picking up stones. So for right now, I'm going to turn off basically all of our pickup logic, because this is still just jacked for now. And I want to, right now we're saying if up is pressed and our movement origin grid has more than 0 occupants, which isn't exactly right. What we want to do is we want to save as a value stones picked up, like stones picked up. So as soon as we click in a move type move, here we increase these occupants of our mouse stones. So after that, we need to say that our mouse stones occupants, that number, so it's how many stones we've picked up to 5, gets assigned into our stones picked up. So this value gets set to be the amount of stones we have picked up, and then why is this? Oh no. Oh, it's because this. So yeah, we need to do, this is where we need to add this. We need to say, and the mouse stone occupants is smaller than the number of the ones we picked up. So if there's all the occupants, say we pick up 3 stones, 3 stones is not less than 3 stones picked up. Therefore, when we press up, it won't work. But then we would need to, if we press up and our occupants is less than our stones picked up, then we need to increment our mouse stones occupants. So we can at least try that now and see if that is now at least not letting us pick up any more than we have. Let's see. So mouse stone occupants 3, drop 1, there's 2, drop 1, there's 1, drop 1, there's 0. Now if we press up, we have an occupant in our mouse stone, which is right, 2, 3. Now if I press it one more time, it shouldn't go to 4. And it doesn't. So that's working. We just need to tackle how to exactly do this, because so let's turn this on and see. I mean, this is wishful thinking here. I'm wondering if I fix the if loop, that if it doesn't crash, but it does. So 372 is where it crashes. And it's right here on the first thing, trying to index a nil value. Now it won't tell us what value is nil, but I'm guessing it's this monster right here. So in our origin space, let's add a note here what this is actually doing. This is I'm just going to put in a 1 right here for now. Our pickup index was kind of jacked, but let's take this. Why is it? Why? You're fine with that? I must have missed a bracket or something. So look, this is supposedly copying. If we pick up a stone, we need to, actually this is backwards, yeah, we need to copy. Okay. I'm just actually wondering what this pickup index gets assigned to. and how that's kind of working. We start at 0. Are we really not doing anything with that pickup index? So how do we know? God dang. Okay, so if we pick up a stone, we need to do a couple things. We need to copy movement origin stone into mouse stone at appropriate index. We need to nillify nil the topmost stone in our movement origin grid, and then we need to increment occupants we need to update occupants. And I say update because we need to increment one and decrement the other. So we're actually doing this a little bit backwards here. We need to move this value into our mouse stone's value. So we had that backwards. Now, what index are we trying to move it into? Let's see. This is what we were trying to figure out yesterday, but it was very tricky. So if I pick up 1 now, it needs to go, gosh, yeah, okay, so this is why I was rendering those values on the stones themselves, because it has nothing to do with the occupants, but it has to do with the stack order, which is tricky because, so the white outline one, gosh, I can't even. So like this one is stack order 1, this one is stack order 2, and this one is stack order 3. So when we go to move, when we go to move it, when we go to drop it, if we want to pick this up and replace it, we have to put it back at stack order 1 of our mouse stones. But how do we know it's stack order 1? Oh my gosh. Because the thing is, the stack order changes once we pick things up. If we pick up more than 5, the stack order is totally different. So we need to define the stack order in terms of our mouse stones so that we can kind of ensure we're picking up and placing the right stone. So how do we say, like if we drop another one, how do we say, that the only stone that's visible in our hand right now is a stack order 3. So therefore, we would need to pick up a stack order of 2. It's like, how do we do that? Yeah, because right now, all of our stones in our mouse stones are still objects inside of our mouse stone. They're members inside of our mouse stone object. They're just nullified. Stack order 1 and stack order 2 is nullified as a stone type and stone color and a stack order currently. So how would we get the first stone? We would need to get the stack order of the first stone that isn't nil. And then say, if we pick up a stone, we need to put its stack order at one below whatever our current bottommost mouse stone stack order is. Jesus. This is really tough for me to try to wrap my head around. And actually, if we have a stack bigger than 5, the stack order will be actually not reset to 1 through 5. Oh, see, that's so tough. Because depending on the stack order will adapt its shape. So, for example, if we pick up, see, for right now, this black stone is smaller than the white stone, but if we drop it in, this space, for example, it shouldn't keep that smaller shape. It should actually be the full size of that grid. So we need to assign the proper stack order upon dropping and placing too, which we haven't done yet. This is so difficult. We need to do something that will return the stack order of the lowest unnilled mouse stone object. So it's almost like we need to say, like, or like it's 1, 10. So for each member in our mouse stone object, if it is not nil, then save the stack order. No, we want the lowest. So maybe we go... Yeah, maybe we actually decrement. So maybe we say 10 to 1, comma, -1. We start at the 10th member, and we cycle down, and we save each mouse stone member. We need its members object at the ith location and its stack order to be moved into a value called lowest mouse stone stack order. Jeez. So lowest mouse stone stack order, and we only assign that if the mouse stone's member at that I position, if its stone type or stone color or stack order, maybe we just do stack order to be simple, if that stack order does not equal nil. then we save it. So that way, let's say we pick up 3 stones, we drop 2. We have a stack order of 3 stone in our mouse stones still. Every member lower than our stack order of 3 will be nil. So if we start at the 10th member, and if it's not nil, we do something. If it's nil, it won't do anything. So it'll get to that 3rd stone. Its stack order at that index won't be nil. Therefore, it'll put that member's stack order into a variable called lowest mouse stone stack order. And then, for example, it would keep decrementing in the loop, and it would say mouse stone members 2.stack order, but that would be nil because we nullified it when we dropped it. Therefore, it wouldn't overwrite this lowest mouse stone stack order. So if we print up this I'm gonna say lowest stack order here, like this. That looks low stack order. I don't know. Low stack order, and we're putting in that lowest mouse stone stack order variable there. Let's see if that is doing anything for us. So if we pick it up, lowest stack order is nil. Now it's 1 because the first stone is our lowest stack order. And if we drop it, we've got 2. If we pick up 1, it should increment it again. But we're not actually populating our 1 again, so I guess that makes sense. But look at this. So yeah, we've got a lowest stack order of 3 right now. So that looks like it is tracking. That was jacked. Well, that makes sense because we're still working on the up logic, but it's looking like this lowest stack order is working. So in our move detection here, we need to swap these values. So we need to put, instead of pickup index, it's now the lowest mouse stone stack order, and we need to swap this. This is what needs to be copied into. So we put it on the left, we assign this value into it. And then same with this. We're assigning the movement grids fields into our mouse stone members at our and it's not just lowest stack order, it's actually lowest stack order -1. So like the stone right beneath our current lowest stone. So we put in our lowest mouse stone stack order here, but oopsie, lowest mouse stone stack order, and it's actually that -1. Because we're not trying to overwrite the bottom lowest stack order stone, we're trying to populate the stack order right beneath it with the appropriate stack order. So then the render goes from stack order 1 to 10, so we shouldn't have any render issues like that, but we need to nullify the topmost stone in our movement origin grid, which it looks like we do. Then we update occupants. Let's give this a shot. Let's see what this looks like. I'm just hoping it doesn't crash when I pick something up, you know? So we drop. Let's pick up. Oh my god. It worked once. Oh, well. It's very jacked. It worked for the first stone, and it doesn't crash, which is a... look, if we drop this stone, lowest stack order 2, so if we hit up, it should put... oh, wait. Lowest stack order 2. Yeah. So it should put... stack order -1 would be a 1, so it should put the movement grid stone 1 into a stone 1 of our mouse stone, which it does. It's just that gets jacked. So it doesn't, our lowest stack order doesn't get incremented when we pick up a stone, which it should. So when we pick up a stone, we need to increment our lowest stack order. I think. Yeah. So if we're pressed up, then our lowest stack order gets actually incremented. And maybe that will help the render bugs. Let's see. Drop 1, pick up 1. Lowest stack order is 1. It's still jacked. Yeah, way jacked. Let's see here. So lowest stack order is 1. It becomes 2. We need to... No, that's correct. Oh god. I don't get why it crashes. It's getting there. It's close. Let's see again. So mouse occupants is 3. Low stack order is 1. That's correct. If we drop it, lowest stack order should be 2. Occupants 2. It is. Now if we pick this up again, it should be 3 occupants. Lowest stack order of 1. Look at that. We have 4 occupants in our mouse stone now, which is incorrect. So if we... How is that getting messed up? How are we... If we press up, we're incrementing our mouse stone occupants. But if we press down, we are decrementing... Oh, we are not... No, we are decrementing it. Huh. So how come... Mouse stone is 3, 2, yet when we pick this up, it becomes 4. How does it skip 2 mouse stone occupants with 1 press of a button there? Oh, we do it right here. We increment it twice here. We already had this. Okay. See? Why? So look, mouse stone occupants 3, it's 2, we pick it up, it should be 3 again. It is. Lowest stack order is 1, that should be right. Yet when we drop another one, see look, why did it drop? It dropped the second stone. It dropped the second stone instead of the first stone. Stack order 1, stack order 1. What's different there? Why would it drop the second stone the second time we do that? God. It's 373. It's still messing up here. I'm confused. Why would it drop the second stone the second time we do it? We drop it here, it drops the correct stone. Yet, We have the same stack order, the same occupants, yet when we drop it the second time, it drops the stack order of 2. So why would pressing down drop? Oh, we need to... The bottomStone index is what's getting messed up. Now, our bottomStone index, are we printing up this bottomStone index right now? That's the value that's screwing it up, I'm pretty sure. We are not printing this up. Let's, instead of first stones drop, let's print up that bottomStone index. We're gonna do bottomStone index. I think that this is the one that's messed up. So bottomStone index. bottomStone index. So bottomStone index is 1, it's 2, yet when we pick it up, it stays 2. So when we pick it up, we need to minus a bottomStone index once we pick it up. We need to decrement our bottomStone index if we pick it up. Now, the bottomStone index was a value that we're using to drop if you look here, our bottomStone, I'm trying to remember exactly what I did with this. bottomStone index starts at 1 because if you pick up any amount of stones, or when you pick up stones, the stone at your member 1 oh my god, Dad, this is so tough. I mean, I'm just imagining picking up 5 stones off a stack of more than 5 stones, it'll get all screwed up. But let's just see if we place up, if we fix our bottomStone index, we decrement it by if we pick it up. Because the bottomStone index decides which one to actually drop. So we need to keep that value the same, or, tethered. That's right. That's right. Oh, and then it didn't render. So close. At some point, it stopped rendering our top stone. So we can drop 2, no problem. But when we drop 3 and pick up 1, it's still okay. But when we pick up a second one, it stops rendering it. We still have 2 occupants. It still looks like it's there, it's just not rendering it. It's because our bottomStone index is so jacked. Yeah, it's because our bottomStone index is jacked. I don't know how to fix it right now. We almost got it. We almost figured it out. We take a look at our git diff. We added a stone picked up variable. We took out our pickup index and we instead starting to do We assign our stones picked up to our occupants upon a click. We fixed our pick up logic by assigning the correct thing into the correct thing. We're still jacking up our bottomStone index logic. We probably need to rehaul how we're doing this to make it inclusive of picking up 5 stones off a stack, because, well, no, wait, because it's like, I don't know. The adaptive sizing of the thing based on stack order is what we are totally neglecting right now. We're not assigning the correct stack order depending on what's in the grid that you're dropping it in. But that doesn't exactly matter just yet, because right now we're only doing stones if you pick up an occupant's less than 5. God dang. It's so confusing. Yeah. Let's git commit, and it's we started fixing stone pickup logic, and then I'll leave a note saying bottomStone index busted. Git push. Okay. Well, we know we need to fix our bottomStone index. And that would fix our render for our third stone. But it's almost there. It's kind of working. It's just that when we drop all 3, our bottomStone index gets jacked. So we'll have to figure that out. I'll catch you guys tomorrow, and we'll hopefully figure out some of that. Wow, look at this stack they got going on. This is 3, 4, 5, 6, 7, 8, 9, 10, 11. Our game is locked to a stack of 10. This is a 6x6 though, so I think a 10 is a reasonable stack limit. You can't render them any smaller than that reasonably when I was doing that testing, so I feel like the stack limit of 10 is an unfortunate but necessary limit to developing the digital version of a 3-dimensional game. The 2D version of a 3-dimensional game. It's just, yeah. I don't know. Anyways, catch you guys tomorrow. Hopefully we'll get more updates.